Welcome to AI Native Builders Forum. The original idea that Vikram from Needle, myself, and Venkatesh Sitaram from the Valley, Spotonics, you might have seen the standees. Our idea was that the community is now reaching a certain critical mass and that we should be able to accelerate this whole process of deepening the ecosystem. And for this, we were inspired by a number of different institutions that were created in the Valley. One of them is called AI Engineer, where senior technical folks would come and share the best of their both experiences, ideas, products, and so on. The ecosystem is not at a place where we can build something of that scale. Think of this as a lightweight version, but we now are able to get started on the journey of making us a lot more Silicon Valley-ish in terms of ideas, depth, speed, execution, and so on, and going after global markets. So what you're seeing here is a lot of founders and senior technical folks who are driving this whole activity. The idea is to bring a bunch of folks here, people like you and me, to get into the next level of detail. When we started talking around with the founders and senior technical folks, everybody has ambition to go global, deepen the whole product, deepen the teams, and so on. But there was not a place where the founders and builders could come together to discuss all of all the different challenges that they face, right? Whether it is from a product strategy point of view, technical, the architectures, the team building, and so on. So the idea is to put an event like this where we'll bring all of the folks together. This will only grow from here. Our ecosystem is in very early stages, nothing of the scale or the speed of the Valley, but we're catching up, right? In terms of ideas, institutions, and so on. So Vikram, he's going to help you on with the overall program. I have a few logistical notes overall to share with you. First, that we have a few interesting folks who will be joining us. Not only Dane who is a CTO of Cloudflare. He'll talk about global scale systems and so on. But we will also have Anupam Datta from Snowflake and Rajiv Rastogi from Amazon and so on. They will be joining us later. There's a whole group associated with them that has not yet shown up. They will hopefully come. You'll find two other things. One is there is a QR code at the top. This will take you to a system called Slido, where you will be able to, without creating any login or anything like that, you will be able to ask questions there. One of us will be monitoring the channel and then either using it during the session or after the session. The point is to have these kinds of intimate and in-depth conversations, and we'll continue this beyond this event itself. If you can't read the QR code, there is a number also in the Slido. If you enter this number, that will take you to the right channel. And every session has a slightly different code so that we can separate out the discussion. The other one that you'll notice is that there is a Twitter hashtag. Use that if you want to comment, post pictures, and so on. Continue the conversation on X. The third thing here is that we will have a couple of panels and then followed by a fireside. By that time, you will have a lot of questions to discuss. Outside, we will be arranging for tables where you can sit and get into another hour-long conversations with your peers around different topics. We have made arrangements for tables, and we'll assign each table to a topic. If you are interested in RL, you can go to table number 3. and all the folks interested in RL could sit down there and talk about it, for example. So the other last thing that I wanted to mention here is that there will be anything that is said here in this forum should be considered personal views and not the views of the company itself. And anybody saying anything, you are implicitly giving permission to use this. We will be putting this on YouTube. Okay. There will be a couple of breaks at the end of first session. Around 3 o'clock, we'll have a break. After half an hour, we'll come back and have 2 sessions back to back. After that, there will be high tea. There you can park and have extended conversations. I would like to acknowledge the folks who helped put this together. It is, of course, Vikram from Needle, Venkatesh Sitaram from Spotanix, came all the way from the US for this. And, of course, our sponsors and so on, which we'll be talking about later on. BG, who will be here helping with the fireside, helped both fund this as well as steer a bunch of the evolution. So he will also be here. Okay, with that, let me hand off the mic to my colleague, Vikram, who will be your MC for the rest of the sessions.
Hey. Thanks, Venkata. And I think we're sort of running late. It's already 23 minutes past 2. So let's keep this quick. So we have 3 sessions today. The first one is the AI modeling panel. That will be a 45-minute session. I will give you guys a 5-minute warning before it's time. We will have time for questions, but let's keep the questions at the end of the panel because I think that helps with the flow of the discussion. The second session is on AI engineering, again, where we have amazing speakers. And the final session is a fireside chat that Venkat spoke about that we'll have with Bhaskar Ghosh, Dane Net from Cloudflare, and Rajiv Rastogi from Amazon. So for the first panel, I'll invite our 4 panelists. We have an amazing panel here. We have Gaurav Agarwal, who's going to be our moderator. He's the VP, head of AI at Geo Platforms, has had a distinguished career. I'll let him introduce himself. We have Vijay Gabale, who's the founder of Infilect. We have Arvind Saraf, who's at Microsoft Turing. And we have Mahesh Satyamurthy, who's the founder of Bespoke Labs. So with that, let me welcome you folks here.
Thanks, Vikram and Venkat, for having us here. And like Arvind, I keep meeting, once in a while. But Mahesh, I have heard of him, but meeting him for the first time. And Vijay, we have been spending time on LinkedIn, Twitter together, but never met in life, although we both live in Bangalore and digitally known each other for a decade, I guess, right? Or maybe more. So thanks for having us here and just having this get together more than anything else. So my name is Gaurav. I hate this term. So I'm just AI guy at Reliance. There's no head or tail there, I guess. I have been in the area of AI when my elder brother actually was worried whether I'll get a job in AI because it's like, in 2002, I went for a PhD in AI. So people thought like, what is this? It never used to work. There was only the zip code reader was the only application that used to work that time. Not even the face detection on digital cameras. Digital cameras were they are very new back then. Without wasting much time, what I'll ask first is, because this is more of not a Gyan session as such, that we will just say things which are there online already. It is more of we'll try to make it more technical and useful and give anecdotes from, the problems we face as actual builders and our thumb rules, hacks, whatever work. So I'll start with, we will ask the questions first, 2 or 3, just to sample the audience and what is in the top of your mind as a builder. This is a model tuning or fine tuning panel. So why don't few of you raise your hands and just briefly tell us what is on top of your mind so that we can contextualize. So it's like a jazz. We are not well prepared. I rarely prepare. So I hope these guys will also bear with me. So we have no agenda, but I think we are, crack enough that we'll figure it out. So please.
The question here is basically, I would expect to get more anecdotes about what kind of agents, if we build, how they interact seamlessly, how they can understand the boundaries and interfaces. If you guys have faced any challenges and solved them, that will be helpful. Sure. So agent builder is the new term.
Great, yeah.
For a narrowed focus of AI, how would you do the evaluation in respect of the validation of the AI in the narrowed domain? So let's say you would say quick commerce, right? And if you want an AI agent system to be, let's say, the the level 1 help for quick commerce, how would you validate the
how will you set up evaluation
for the range of inputs that, let's say, Amazon might face across all the product categories it has?
Great questions. I think now with that we'll get started, and I'll see if I remember, or I'll leave it. It's okay. We are not that formal anyway. So I'll just introduce our 3 panelists here. Vijay, the person who I have known for over a decade and never got the chance to meet despite being in the same city. He runs Infilect. Infilect is so he will describe it's a product company that helps CPG companies to figure out how their brand is being sort of displayed on shelves in the stores. Then we have Mahesh, again another guy. We used to be colleagues at Google, never met I guess again. Here at least the reason was he was in Bay Area, I was in Bangalore, so we were not lazy there. But yeah, Mahesh runs Bespoke Labs. And he is probably closest to doing fine-tuning and making models dance to his tunes for a living, right? He better does it well. Otherwise, like he runs a startup, so he better does it. And we have Arvind, who is okay. I won't get to the personal intro there. Otherwise, he'll beat me up. And he's also one guy who's no, he's not violent. He's not violent, but he's also the elder one here, right? In age, so. Yeah, he's part of the Turing team here at Microsoft, and this is the office he works from actually. So he can be our host today. So Arvind has been IIT Bombay, Kanpur, then brief stint at MIT. Then he has been entrepreneur. He has worked on textile. What were you saying? I had no idea. Okay, you will describe. That's okay. So. Yeah, so I'll start with Vijay. So one round, what we'll do is we'll try to see in our anecdotes how we address these 3-4 questions that are asked. Not answering them exactly, but at least giving anecdotes which sort of address them. Maybe you can, Mahesh, you wanted agentic, so maybe that's where we can address that question. Others are around fine-tuning and evaluation framework, so I think all of us probably can cover that. So let's start with Vijay.
Sure. So just to talk to you about myself, I finished my PhD from IIT Bombay around 2012. And then I worked with IBM Research Labs for 3 years. And then I started Infilect. So what we do at Infilect, so physical retail, your DMarts or Reliance Retail, over 90% of retail is still physical. Even in India, e-commerce is less than 5%, right? So if you think about companies like P&G, so P&G would sell their products across a large number of stores, and they don't know the kind of shelf space that they occupy on the shelves. So if you walk into a store and if you go into, let's say, biscuits category, right? So you have, ITC or, Parle-G. They don't have understanding of the shelf space that they have on the shelf. So what we do is we give these companies a very simple to use app by which their sales reps basically take pictures in the store. And using those pictures, we basically extract data about which store has what kind of share of shelf. And that basically helps them to understand the stores where there are products, overstocked or, out of stock. Um, Today we are, a global. We are, alive across more than 10 countries. It's been, 5 years, since we have been doing this. I'll take these two questions in terms of have we really seen results of, fine tuning on, large language models, right? So our problem is more of a, computer vision problem, right? It is not about text. But what we have done is we have taken, vision transformers, and because we have over, 100 million pictures that we have covered from different parts of the globe, we have, fine-tuned them, right? So when we used, for instance, OpenClip, these are some of the models that are there in, vision space. So when we use these models initially, we got, MAP of about 70%, right? And when we fine-tune these models, we got MAP of almost about 95%. And of course, it took time. It took a lot of cloud compute, but then eventually we got the results. And especially in our space, it is highly important to have very high accuracy of our models. I mean, if you go and tell a customer that your stock is not present in the store just because our AI models didn't really identify them, then we basically incur penalties, right? So it's very important for us to have models which work at very high accuracy. So that's one example that I can give. As a startup, as a engineering company, I'm building the infrastructure of engineering so that data flows from one side, you train models all the time, and then you deploy them. That is something that you need to build or you can borrow. In our case, we didn't really find a platform specifically for computer vision which we can borrow, and that's why we had to build it. But that has become our moat now, right? So we can do very frequent model updates, and that basically helps our customers to understand what's happening in the stores.
So I was leading this Amazon ads moderation. So you can imagine any ad which is questionable and it goes to the user, how much of a brand damage can happen. So we used to handle a golden data set against which we will do the benchmarking almost every day. Like we used to have there's a human and AI interaction, right? We can't just live without humans. So humans used to play a role to bootstrap this whole golden data set. And at one point of time, the golden data set will automatically improve or update itself. So it is possible. Even the legal AI, we can't give them, if lawyers are working, we can't give them 90% accurate results.
So just to add one more, technical aspect, we use what is called as Swin transformers, which was basically published around 2022, and we found that they were lightweight. They could, learn fast. They would take less GPU compute, which can, save us cost, and they would also run fast, when we do inferencing. So the choice of model that you're going to fine tune also matters, and that will basically help you from long-term perspective.
So would I be right if I said that this trained model is now biased towards images that pertain to store shelves?
That's right. I mean, that was the purpose. The purpose was to build a vertical AI, which can work with very high accuracy. So the same model may not work, let's say, on e-commerce pictures, but it will work very with very high accuracy on the kind of data sets that we have. And the thing about us is that taking pictures of retail shelves is not something that is available on the web. So we can't really scrape the data, right? So so that also helps us to build a moat where these models can boost the performance of our product.
I were to present a medical image, that shows sort of similar patterns, geometric patterns, let us say, right? Would that model start working on medical images is my question.
Absolutely not, because you have to fine tune the base model on the kind of data sets that you have to get good accuracy, right? Yeah, and that is what I mean. If you see, most of the startups or companies would take open source models which are trained on very large scale data sets, but you have to fine tune on your specific use case, and that is where it will basically start giving you boost.
Hey everyone, my name is Mahesh Satyamurthy. I'm co-founder of Bespoke Labs, and before this I was at Google DeepMind training LLMs and multimodal models for recommendation use cases. So I've deployed a bunch of stuff to YouTube. So a lot of if you like YouTube recommendations, it's me. If you don't, probably my teammates. So yeah, I think after my stint at DeepMind, so also one other thing is I was an engineer, but also did a whole bunch of research there. Came up with something called generative retrieval, published at NeurIPS for recommendations, where the idea is to actually not use retrieval. So a lot of people, when they build, retrieval systems or RAG systems, they rely on a retrieval and model and then pass it on to LLM. Here, the goal is to teach all the knowledge to the recommendation, the LLM itself, right? So that kind of stuff was something I worked on, and then yes, I co-founded Bespoke Labs. And yeah, what we do is we actually bet on fine-tuning, I guess. So like Gaurav said, we better make it work, right? So in fact, we do have some data points to prove that fine-tuning works. So we trained sometime back, last year actually, trained a model which is for a specific use case called grounded factuality. So it's detecting if something that a LLM is saying is hallucinated or not. And for that particular use case, you can use any of the existing closed models. But we fine-tuned a model for that use case, and it actually exceeds the performance of all, like for example, 4.0 and 3.5 Sonnet and so on. So that was one example, and then we also trained a model for chart understanding, which we could exceed the performance of 3.5 Sonnet and Gemini 1.5 Pro, which were all good models. But and then also, yeah. So in general, at Bespoke, we work on post-training, and the thing is, our opinionated view is to focus a lot more on the data itself. Like data is ultimately the critical thing, right? So all the models are sort of democratized in the sense you can take any of the open source models, and the training infra and all of that is kind of also there. What is important is the data, right? So actually it goes back to your question as well as like, it's what you want to think is what's in distribution versus out of distribution. So if you, so your data has to be in distribution to what your eventual, use case is going to be. So how do you curate the data, and then also how do you put your enterprise data to use and so on. So that's kind of what, that's the viewpoint of how we do things. And recently we are working also on reinforcement learning and reasoning, and we had this project along with many others in the industry and academia, Stanford, University of Washington, UC Berkeley, on creating an open reasoning data set. The project is called Open Thoughts, and basically our goal was to, so what happened was when DeepSeek announced their R1 model, they open sourced the, of course, the reasoning model, the 670 billion parameter model, but also the smaller ones, but they never released the data, right? So we set out to create the data, and also our goal was to actually exceed the performance of DeepSeek R1 itself. The smaller ones, the larger one is harder. So we ended up, after a lot of effort, creating an open reasoning data that when you fine tune, you get a model that actually exceeds the performance. So that was done sometime recently. Yeah.
Hi, my name is Arvind, and I just like to begin with a small story as a grad student back in 2001, because it's very apt whenever we have these AI forums, right? So this was a introductory AI class, and there was one specific lecture on neural networks. And remember the professor, I think Leslie Kilbling, I think she began with the preface that, look, we're just doing neural networks for the sake of completeness and breadth. You'll probably never use it in your lifetime. And here we are, where AI probably means neural network for all practical purposes, right? So, so in terms of background, just filling in where Gaurav started, computer scientist, did a bunch of impact tech ventures earlier, last ran engineering for an AI venture which Apple acquired, and at Microsoft for the last 15 months right now. So I work with the Turing team, which is fundamentally led a lot of new deep learning initiatives within Microsoft. I think back in the days, also did the first few large language models, which were SOTA for a while. This was even before the popular ones that we know now. And now we work on the Copilot, pushing out a lot of frontier ML innovations inside it. To some of the questions that were sort of asked, right? There was this question about agent, how do you sort of define the boundaries of agent? Hard question, especially in a context like us where we have multiple products and you would want an agent to act across them. I think, and that's also is fundamentally the difference in a narrow sense of how we perceived LLM, which is just giving information versus agent, which is sort of acting on our behalf, right? And I think this question still stays. I think one possible approach I've seen amongst many that companies and products adopt is, instead of completing an action, can you do a handover to a tool, right? Prepare everything, hand it over to a tool. If I'm asking you to send an email, prepare that email and let the sort of use some sort of a confirmation could be baked into the existing sort of products is one approach that I've seen work. There were also these questions about SFT, right? I think I know it's already been answered, right? So there's earlier remarks about task specificity become very relevant. Historically, people have used supervised fine-tuning or fine-tuning for question answering, and if you're using essentially creating this SFT on the same data that probably similar to what exists when it was on similar to what it was pre-trained on, not much value, but targeted SFT I've seen work. Questions about RL as well, right? I think interestingly in multi-step thing I've seen RL work well. Are there equal and low rank adapters? Not sure, but I also think the current approaches have been fairly optimized, right? With much more simplified reward functions. Possibly, I don't know if people have tried taking a LoRa kind of an adapter on an RL model and doing a backprop on it. I'm sure there must be papers about it. I've not followed that space. So, but I think even without those, there is a lot of juice to be extracted in the work stream that we have seen.
I think before we get there, I think I will just have it's again an opinionated thought. I think we will get to an era where, today we expect a model, a generic model to have, it should be a neural physicist or, it should be a quantum, person, it should be a mathematician. You expect that model to do everything. That's what these large models are. But I think we will get to an era where, that's not what intelligence is like. Again, it's a debatable thing, but most of us probably are not expert in these topics, but are we are probably fairly decently intelligent, whatever. But we know if we are serious about it, if we have to do it, we can figure it out, we can learn it, or find someone to teach us. So I think that's the era we will get to, where I think, we'll redefine intelligent models where they know how to do it rather than they knowing it entirely. That will, so every model may be very, very small, but it's like an army of models, but they know what to do when. So I think your question will be even more relevant there. So we are not talking about some 10, 15 agents communicating with each other. I am imagining like maybe more than that, tens of thousands, millions of things. That's how even a computer system works, right? Yeah, so that actually, and that will again be trained. That will not be, that orchestrator that you're talking about. That will be the smartest. That's like the maestro. The maestro has to work. It has to know everything. How they behave. What are the latencies? What are the failure modes? All of them will be imperfect. I think that's where we are getting to. Whether these MPCs and A2As and these things are right abstractions for that eventuality, if that happens, if I'm even vaguely right. Maybe not, but these abstractions are at least a step towards that.
And when to ask the user himself or herself, right, as for approval, right? Even knowing that probably. Yeah.
Exactly. So I think if you want to have another round before we ask more questions.
I just want to share one example story of how we used agentic AI. So when we work with CPG companies, many a times they themselves don't have access to their catalog, which is a funny thing because, So when pictures are captured in the store, let's say I'll just go back to the same example of biscuits category, right? So you see Good Day biscuits and Mare biscuits on the shelf. Suddenly, let's say there is some choco chip cookies kind of biscuit that comes in. Now, that particular pattern is never seen by the AI model, so we need to name it to say that this is how you should, predict that particular pattern. And we also have to do, a UPC level prediction, right? And that, UPC is not really, visible on the packaging. It is sometimes on the, back of the packaging. So what our team does is they basically take that packaging, then you do a web search. I mean, you can also put an, agent for that saying that, this is a packaging, find me the UPC for that. And then we have a very simple UI where you can put that packaging and then say that this is the UPC of that particular packaging. Now this entire thing, what we did is we recorded videos of someone doing this, 10 to 15 people. So it is a screen recording, right? And then we gave it to LLM. And then say that next time when you see this particular screen, can you do these clicks? And to our surprise, it was like a wow moment where it's like suddenly you can see that some jobs will get replaced, right? Because now I know it is getting recorded, but this is the fact, right? And this is the fact, and this is already happening. So all the mundane jobs will or are already getting replaced by the agents.
I think, I don't have opinions on the boundaries, but in general, what we see is that RL reinforcement learning is working, pretty well to fine tune these agents. And also, I think the other viewpoint is like a lot of people build these agents based on like a cascade of prompts and so on. The thing that's missing is like once you build this agent, you know if it is working or not, right? So then if it is not working, how do you take that feedback and improve the agent? Right now, again, it's like human intuition driven, right? Like you have to kind of go and modify one of the prompts somewhere, hoping that the whole thing works, and then something else fails. So there is like this cat and mouse game, I guess. I think taking a step back, there is something called bitter lesson that David Silver and Richard Sutton wrote. The whole idea there is that what they claim is what they say is like systems that learn or use compute to learn scale better than what humans can add to the system, right? So for example, we have had people building computer vision models by hand engineering features, and then they moved on to deep learning, where the model itself learns the feature engineering. And LLMs are scaled up versions, and they are kind of learning a lot by themselves. But now prompt engineering, what it's doing is like it's adding a lot more human intuition into the system, whereas reinforcement learning, the whole point is if you can architect the system so that it takes your initial prompts and then it actually, you have a way to figure out if the actual answer produced by the agent is correct or not, then the model itself should be able to learn, the agent should be able to learn itself, right? So that's the bitter lesson. That has held true for a long time. So my view is, at least going forward, of course, closed models are getting better, but at some point, they also have diminishing returns, but you should be able to customize a lot better of these models, for your enterprise use cases and for your data and what the feedback you are getting, right, using RL. So that's my take. So the question is, what percentage of your curation is by humans versus synthetic? How do you verify synthetic data? Yes. So, I think, so what's happening also is like the LLMs are getting, better and better, that you can actually curate data quite a bit using LLMs itself, right? So, sometime back there used to be Mechanical Turk where humans would generate data. And, after that was a lot more low level. And then, what's happening is like, bit more of the experts were writing these questions and answers, like the data that OpenAI and all these frontier labs would buy. And now what's happening is like all the LLMs are good at generating, fairly decent synthetic data, but only when you actually have to train models to, exceedingly good quality, then you need expert data. So that's one case. But also if you have different use cases within your company where you have your own expertise, right, that for how things have to work, then you have the human curated data. But in general, the trend has been, at least for the frontier models, the synthetic data just works really well. So the percentage kind of overall seems to decrease. And you can do a lot of other clever ways of putting together LLMs to kind of make sure the quality is good. You can have various ways of checking for diversity. I think I can give one example from the open thoughts work we did. So again, as I was saying, the open thoughts work was to curate very good quality reasoning data set, which you can use for supervised fine tuning and convert a non-reasoning model into a reasoning model. So there the goal is now, how do you create good quality data? So again, we had the choice of getting expert data versus, human data versus synthetic data. So it ended up that we could basically use DeepSeek R1 and QWQ to generate a lot of this synthetic data. And also we did a whole bunch of things like, okay, we have to do some sort of difficulty filtering, meaning the prompts have to be difficult enough for the model to answer. So you can do all sorts of filtering using existing LLMs itself. So a whole bunch of things can be done just by chaining together LLMs and then curating data. Happy to sort of also chime in on this, right? So Mahesh quoted, I think, Sutton's wonderful essay, right? Bit lesson, right? Just taking off from that, right? I think if you look at, and I'll tie it back to the agent sort of question as well as the synthetic data question, right? The evolution of computing has been more like us trying to capture our own logic to intuition, logic meaning programs, with limited, obviously imperfect, that's why it couldn't do what we humans can do, to our own intuition, which is what the feature extraction and weights and so on, to then now Sutton's article itself, sort of the realization that, look, it's not an intellectual, getting computers to perform well is not an intellect, we should not look at it as an intellectual quest for us to see whether we can teach it that, as opposed to give it enough data and let it learn rather, right? And that's also something we have seen with agents as well, right? So if you want an agent to do a multi-step thing of copying thing from one place to the other, do something, just give it enough data. You don't have to say, oh, if this is the tool, then do this, if this is, or even try to sort of extract features from it. And this is where synthetic data comes in, because this is not the data that exists well in the pre-trained space right now. And luckily, with everything that we know now, with some of the recent work in RL, you could create, because there is obviously this classic generator verification gap. Another article by Sutton, right, which is the age of exploration. Era of experience. Era of experience, sorry. And the RL methods which allow the models to learn from it. So in a sense, I think we are actually getting into a very exciting time with what we can do at a lot less effort.
What we'll do now is maybe another few maybe more targeted questions now that you have some idea on where we all come from. So please.
So once we train a model and deploy in production, and again after few weeks or few days, we need to retrain the model due to the new data. And how do you try to automate this entire process, the periodic retraining in the era of the agentic AI, so that no need to have any manual intervention, and we have certain dashboard to see like, okay, this is the current accuracy and it is able to pass these A/B tests and all. So
I can give some of my experience during the, when I was training model for YouTube, right? So in YouTube, we were training recommender models. So for example, when you go to YouTube, there is a recommender model that's recommending the front page content. And then when you're watching a video on the panel on site. So that's the context. And now what's happening is there is like things evolving, right? The world is changing. Every day people are changing preferences and whatnot. So you have to you cannot train one model and hope it works for a long time. So we have to actually, continuously train. So what we would do is we would, every day when data comes, you would retrain. So there would be some mechanisms in place. For example, we would do something called next day eval and things like that to make sure that the models are as generalizable as possible. But I guess, yeah, to your question, I think the whole point is like, okay, how is the data drift happening? And again, ultimately, what I was saying is like, these models are not magical, right? So they still are just basically learning from the data. So if so you have to see what's in distribution versus what is out of distribution. So if the world is changing and you have new data, you have to kind of adapt. So if you can set up these systems to continuously learn and fine tune, that's another advantage of like systems that can fine tune every day, right? Or continually you do, as opposed to you use using existing models and they're just static.
Sorry, I mean, just to add to Mahesh, I think 2 to 3 things are not going to get replaced, in my opinion. One, firstly, you need to evaluate how your AI model is doing, and to do that, you need humans. I mean, you could sample predictions of AI and then say that out of 100 samples, 50 are correct and 50 are wrong, right? And so you need to know that, and that can be done by humans only. Once you know that these 50 samples are wrong, you need to retag them, and that again has to be done by humans. And only then you can do workflow automation and then say that when you see samples like these which are wrong, you need to train the models and then deploy. So I think some of these fundamental aspects where humans are judges, I don't think those are going to go anywhere yet.
Yeah. No, I think so. Most computer scientists or engineers like me who came from traditional systems, this is one learning we all had to do sort of crossover when we moved into more stochastic AI. Is it doesn't work like unit testing in systems. You need to invest a lot into good eval set. You need to keep updating it and make that almost like the way in good engineering you say, yeah, you begin with unit test, then you write the code. It's almost a little bit like that. You at least need to have a small eval product, prototyping eval set, and then invest into that, and then invest into good setting up that continuous eval of sorts. That's. There is no, as I said, at least I've not seen it work around there.
And actually, I want to add some more stuff, right? So ultimately, what you want is like continuous eval, right? So that kind of tells you, okay, the accuracy is 80% or whatever, 95% today, and then 94% and so on. But eval itself is not enough. What's something that I have not seen people do rigorously is what's called error analysis, to actually understand, okay, where is the model actually making the mistake, right? So there are 2 ways of doing this. One is you can ask other LLMs to kind of categorize things and whatnot. But as a human, if you have to actually read the output, if you can just, this is something underrated, is like reading what's happening, looking at the data and so on, visualizing. That gives a lot of intuition to say, okay, this is where now systems are starting to fail. That's like human-based error analysis. You can also do LLM-based error analysis. And then it informs you, okay, maybe now the model is making mistakes in this category. So you can either generate more synthetic data or like figure out something about your logging to get the right data for fine-tuning. Yeah.
So there's a constant debate over RAG versus fine-tuning. And this is focused for research kind of application. For example, investment research or legal research, you want to build a second brain. So when do you decide that you need to go for fine tuning? Number one. My second question is, how do you evaluate the open source models today? Which open source models to go for fine tuning?
Here is one fun fact, actually. The RAG paper, the paper that introduced RAG, they actually fine tuned the LLM.
Do both. So why choose? Yeah. They are complementary, always. I mean, serious people do both, seriously. I mean, why do you want to pick?
And if you're pressed for resources, I mean, then try RAG at least, and then add fine-tuning when the quality isn't good enough, then.
There's no religion here, right? I mean, just do both. I mean, sometimes it's hard to say which one will do better, actually.
See, one thing I want to share is that When we started training models around 2015 time frame or so, and both Mahesh and Arvind will agree that it needed something like 1,000 samples per class that you need to train your models. 2020, that has come down to 100. Now it is just 10. So I don't think that, I mean, the task that you have, you can quickly fine tune and then you can go ahead. That's what I say. Yeah.
I mean, you can almost do in context learning these days, right?
He had a second question of picking the
Yeah,
model.
what kind of open source models that I can evaluate before going for fine tuning? What are the evaluation criteria or checkpoints?
I mean, it is a function of domain in which you operate. I think these days there are a lot of models which are, domain specific. For example, as I said, clip model is something that is tuned to convert, pictures into text, right? Which is what, suits us. But I think, depending on your domain, you'll have to choose the model.
I think it goes back to the session on eval set. So a pre-fine-tuned model which does less bad on your eval set, that is the best chance to do better, right? So going back to the same thing actually.
And also the other point would be the cost, right? So basically you have a few different trade-off points, like what's the cost looking like, and then even within cost, it's like, okay, how much resource for fine-tuning versus inference? If you use mixture of experts, it's different. And then, just looking at evals.
Do you have industry vertical based models? Models for industry verticals? Is that a possibility you guys have in mind?
Sure, yeah, it's possible.
Of course. Okay.
I think taking off from what Arvind said, right, about you would build better agents if you had better data. So maybe a question to you, Mahesh, what would it take, given that you built open thoughts, what did it take to build a better synthetic data set or an overall data set for LLMs that do better tool use, and then you build better agents?
For tool use, for tool use, actually, it's a mix of SFT and reinforcement learning. So in fact, we recently have been working on this particular thing, tool use. So just using RL seems to work really well. And the other thing we do is like, basically what RL does is like what Arvind was saying, it helps teach the model how to do multi-step thing, right? So the place where it shines is it doesn't need as much synthetic data. Whereas if you want to teach the same skill using SFT, then you need a lot more synthetic data, because if you have a multi-step, like then it's kind of combinatorily many combinations, right? So it's kind of gets a bit tricky. But RL, the kind of limitation of RL is that the model needs to actually be able to solve to begin with. So what RL is doing is like sharpening the model, right? So if it's basically letting you do trial and error and then teaching the model. So if you never succeed, it can never do things. So there are a bunch of techniques. There is something called mid-training, which kind of teaches the model a bit more, and then you can do SFT and then finally RL. So yeah, things are evolving, but I think you can, most general open source models are already pretty good. So you can start with RL. If it doesn't work well, you generate some synthetic data and do SFT.
Yeah, on the tool use part, right? I think one thing we've seen is the right tool, data with the right tool is important. So for example, if I have a trivial case of trying to append two files, I could say, Achha, generate a code or run a shell command, or I could say open the files in a certain browser and do it. You got to make sure your training data has the right tool that you are, because if your training data has tools using, say, CP command, and then you are sort of wanted to do it in UI, it doesn't work. It confuses the model.
Thank you, Arvind, Mahesh, and Vijay. It was wonderful. Thank you.
Yeah, so thanks, folks. To Arvind's anecdote, right, about neural nets. So I have my personal anecdote. So in around late 90s, 99, I was in grad school, and we had this famous information theory professor who had come from Bell Labs. He'd been working on speech models. And one of my friends went to him and said, I want to do a PhD in machine learning. And he said, forget it, machine learning is just glorified curve fitting. So